Hello everybody. I want to talk through this worksheet here today. I wasn't sure how class would go with our exam, so I wanted to make sure I gave everyone the opportunity to work through this. So we're talking about a relation. And a relation is a set of ordered pairs. And within those ordered pairs, we have two things. We have domain, which are the x values, and we have range, which is our y values. So if we literally just have a list of points, it's a relation right there. There's x's, there's y's, they combine to make points. Our domain is all the x values. 2, -1, 4, 9, 0. Well, range is our y values. 3, 5, -2, 9, -6. You don't have to repeat the x value if it happens twice. You don't have to repeat the y value if it happens twice. You just list out every possible x. Now the next step in a relation is a relation a function or not? So the key thing about a function is it's a relation in which each element of domain is paired with exactly one element in the range. Key thing, x values cannot repeat. All right, that's really what that sentence means. X values cannot repeat. So if I look at my two examples, if I have 5, 5 and 5, -2, this is not a function. And that's because we have the 5 twice. Well, the one below, 3, 5 and 5, 2, that is a function because we have an x value of 3 and an x value of 5. So if we're just looking at points, we check the x values. If we're looking at a graph, we want to do what's called the vertical line test. Now, as you see, the dotted line there, it comes down, straight down, vertical line, hits twice. Since it hits twice, it's not a function. Right? Because in this situation, we have, 2 comma some number there. Well, down here, we also have 2 comma some number. Right? We can't repeat that x value. So hopefully that's a little bit of a refresh on something you learned last year. And, domain, range, function, relation, we're going to build off those. And we're going to focus on looking at some visible graphs. Now, something we learned last year is called interval notation. All right, so brackets indicate the endpoint is included. Parentheses are used when the endpoint is not included in the set. And infinity and negative infinity always have a rounded parenthesis. All right, so writing this from an inequality setting to an interval notation is key. So x is less than 6. We can rewrite that as -infinity to 6, parenthesis, because 6 is not included. X is between -3 and 10, including -3. Bracket, -3, comma 10, parenthesis. Every value between those two numbers, not including 10. All right? -infinity to 5. Union, instead of writing or, we could write a union, and this would be 8 to infinity. So when I write this out, I tend to write smallest number to largest number. It's not mathematically wrong if you wrote it backwards. It's still the same thing, but I keep my answers consistent. All right, so here we go. So when I'm looking at domain, I am looking left to right. Right, and when I'm looking range, I'm looking from the bottom up. Right, so if I look at this graph here, it has arrows at the end. And the key thing to realize with the arrows, it's going forever. Now, it's going forever with a slight tilt to the right up top. It's going forever with a slight tilt to the left on the bottom. So forever, this is going up, but it's also going to the right also. Where forever, this is going down, it's also going to the left also. So if I look at my domain and range, due to the arrows pointed to the right, pointed to the left, pointed out wide, my domain and range are both -infinity to infinity. And because this passes the vertical line test everywhere, this is indeed a function. Now on the other hand, for this one, if we're talking about x values, if I scan across my x-axis, the first x value I have is here. And every x value we have is covered to there. Right? It can be multiple lines, But every x value, 1, 1.2, 1.3, negative 0.96, they're all covered. So our domain here is -3, 2, 3, both included. Range, on the other hand, that's how we check out range. Our first y value is there, and we go up, consistent, 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 and our last y value is there. And so every y value between there is present. So I have -2 to 4, and they're both included. Is this a function? No way. I can draw multiple vertical lines that hit twice. All right, so it fails our vertical line test. All right, domain and range. Domain, x value. There's my first x value. Everything's covered, everything's covered, everything's covered, and we're going forever. So in this situation, our domain is 0 to infinity. It's a terrible infinity sign. Range, all right. This arrow is showing that forever it's going out and down. Forever it's going out and down. So our range here is going to be everything. All right, last question, function. Just got to draw one line. Hits twice, not a function. Okay, trickiest one now. Domain, looking for my first x value. My first x value is at -4. Everything's covered, everything's covered. At 2. At 2, I have an open circle at 2, 3, and an open circle at 2, -3. So technically, my domain does not exist at 2. But right after 2, we pick back up and do the arrow. I go forever that way. So my domain here is -4 to 2, union 2 to infinity. Right? By doing that union with the parentheses, it says that 2 does not exist. Now if I look at my range, my first y value is here. I go up, I go up, I go up. I got an open circle there, but no, it's closed on the other side, so we're good. Up, 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 up. All right. My graph ends on the left, but no, this is still going on the right. Going up, 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 and then we get to the asymptote. All right, so we're not going to clear that asymptote. So our range is parentheses -3 to 8 parentheses. An asymptote we will always approach. We will never get close enough to touch it. So that's why it's a parenthesis. Now with our function or not, this is a function because it passes the vertical line test. Even the spot where we hit twice, right? They're both open circles, so it technically does not exist. Okay, so that's with the graph. Now, domain of an equation is important also. Now, there's two main things that lead to major issues here. Issue 1, our denominator can't equal 0. Issue 2, negative number under radicals. Okay, so I assess every piece of my equation. So if I look at problem 1, I can't have my denominator be 0. So I could factor x minus 3, x plus 2, and realize here that my domain is x can't be 3, x can't be -2. Every single other number can be plugged into my denominator and give me something. Right? My numerator, there's no issue with the numerator. You could plug in any number up there. But 3 and -2 are the clear-cut, destroyers in this situation. So my domain is -infinity to -2, union -2 to 3, union 3 to infinity. That says right there that every single number but -2 and 3 works. Okay, now, looking at the second one. I got no issue with the denominator. 3 is fine. I got a rat. Can't have a negative under the rat. So let's take our number under the rat. Right? X squared minus 9. It can equal 0 because it's the numerator, but it has to be greater than or equal to 0. So x squared is greater than or equal to 9. X is greater than or equal to positive -3. And so if I make a number line, think about it. negative 3 and 3. Right? They are included because when they're plugged in, they're 0. My question is it between them or outside of them? Well, if I plug in 0, which is right between those two numbers, 0 squared minus 9 is negative, so it doesn't work. So in this situation, the numbers that do work are outside of those. All right, so our domain here would be negative infinity, negative 3, union 3 to infinity. Now if we flipped it around, let's say we had rad 9 minus x squared, right, we would figure out in this case, we would get negative 3 and 3, right, they still work. But in this situation, numbers between work, numbers outside don't. They give us negatives. Right, so it's always, you can make that number line to mathematically figure out what's going on. Okay, so, let me circle that answer. All right, so down here, problem 3. Numerator, no issue. Denominator can't be equal to 0. And denominator can't have a negative under the rad. So we're above, we said greater than or equal to. Down here, we can only set it equal to 0, greater than 0. 2x is greater than 1, x is negative 1, x is greater than negative 1/2. That's our domain. And writing it, technically this is the correct answer. Right? There's nothing wrong with that. But if we wrote it in interval notation, we would have negative 1/2, parenthesis, to infinity. Same answer, different way. With the last one here, problem 4, our domain is all reals. There's no issue with a parabola, no issue with a quadratic. Every single number can be plugged in there. Right? So whereas the other ones have issues, this has no issue at all. Right? So some key things. Right? If we have something in our denominator, all right, x squared minus 4. Anytime we have something in our denominator, set the denominator equals 0 and figure out what doesn't work. If we have a rad, just a rad, or a rad in the numerator, set what's under the rad greater than or equal to 0. If we have a rad in the denominator, slight change because it can't equal 0, x is greater than or equal to 0. All right? If we have a line or a parabola, there are no issues with those, and our domain would most likely be all reals. All right, with a line, the only time the line's not all reals is if it's a vertical line like an x equals. But the real issues, denominator can't be 0, right? Whatever is that denominator, set equal to 0 and solve. Rads can't have negatives, and a rad in the denominator, it can't be negative and it can't be 0.